Hello everyone, welcome to IB Math Solution. Today we are going to start a new chapter called Sequences and Series, and today we are going to study number sequences. So let's get started. Let's take this sequence of numbers, that is 4, 7, 10, 13, 16, 19, 22, 25, 28, 31 and so on. Do we see any pattern? Yes, we do. Each number we can get by adding 3 to the previous number. If we add 3 to 7, we get 10. If we add 3 to 10, we get 13. If we add 3 to 13, we get 16, and so on. Therefore, we can say the sequence starts at 4, and each term is 3 more than the previous term. Each term is 3 more than the previous term. So if we take this term, this is 3 more than the previous term. Similarly, if we take this term, this is 3 more than the previous term. Now here comes a concept of nth term. What is nth term? So we know this is the first term, this is the second term, and so on, the third term, fourth, fifth, sixth, and seventh, eighth, ninth, and 10th. So in this sequence, 10 terms are there that we can see, and others are not written. We simply can say that this is U1. Now here U1 means the first term. We can also denote the first term using small t1 or capital T1 or capital A1. They all can be used to denote nth term. Similarly, we can denote the second term using U2, T2 or capital T2 or capital A2 and so on. Similarly, we can say the nth term can be denoted using un, tn, capital Tn or capital An. So in general, nth term can be denoted using either un or tn or capital Tn or capital An. But for simplicity, we'll use capital Tn while solving our questions. This is the terminology that we are going to use in our questions. Let's go to another sequence, sequence 2. The sequence is 32, 28, 24, 20, 16, 12, 8, 4, 0, negative 4, negative 8. Do we see any pattern here? Yes, we do. And that pattern is, if we take previous term and subtract 4 from it, we get the next term. Similarly here, and similarly here, and so on. And similarly here, if we subtract 4 from negative 4, we get negative 8. Therefore, we can say the sequence starts at 32 and each term is 4 less than its previous term. Let's take another example, sequence 3. Here we have 3, 6, 12, 24, 48, 96, 192, 384 and so on. What pattern can we recognize here? We can see that if we multiply this term with 2, we get 6. If we multiply this term with 2, we get 12. If we multiply 12 with 2, we get 24. If we multiply 24 with 2, we get 48 and so on. So we can say the sequence starts at 3, and each term is twice its previous term. Let's take this example, sequence 4. So the sequence is 1024, 512, 256, 128, 64, 32, 16, 8, 4, and so on. The pattern that we see here is, if we divide 1024 by 2, so if we divide 1024 by 2, we get 512. If we divide 512 by 2, we get 256. If we divide 256 by 2, we get 128. If we divide 128 by 2, we get 64, and so on. Now, instead of saying we divide this number by 2, we can also say, if we multiply 1024 with half. If we multiply 512 with half, we get 256. If we multiply 256 by half, we get 128. If we multiply 128 with half, we get 64, and so on. So we can say the sequence starts at 1024 and each term is half of its previous term. Instead of this half of, we can also say each term is 1 by 2 times of its previous term. We can also use this phrase here. So let's get started with exercise 5a and solve some problems. Write down the first 4 terms of the sequence if you start with 4 and add 9 each time. So if we start with 4 and add 9 each time, we get 4, 13, 22, 31, 40, 49, 58, 67, and so on. So it is asking us to write the first 4 terms only. So this is our answer. Similarly, 45 and subtract 6 each time. 45, 39, 33, and 27. 2 and multiply 3 each time. So the first term is 2. If we multiply 3 to it, we get 6. If we multiply 3 with 6, we get 18. If we multiply 3 with 18, we get 54. That's the answer. 96 and divide by 2 each time. So 96, if we divide by 2, we get 48. If we divide by 2, we get 24. If we divide by 2, we get 12. And that's the answer. Let's go to the next question. 2. The sequence of prime numbers is 2, 3, 5, 7, 11, 13, 17, 8, 19, and so on. Write down the value of u2, that is the second term. What is the second term here? 1, 2. So u2 is 3. u5 is the fifth term. 1, 2, 3, 4, 5. u5 is 11. u10 is the 10th term. 1, 2, 3, 4, 5, 6, 7, 8. So 10th term is not written. So let's rewrite this sequence of prime numbers, that is 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So u10 is the 10th term, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. U10 is 29. That's the answer. Let's go to the next question. Consider the sequence 4, 7, 10, 13, 16, and so on. Describe the sequence in words. So, the sequence starts at 4 and each term is 3 more than its previous term. Write down the values of u1 and u4. So u1 is 4, u4 is 1, 2, 3, 4, 13. Assuming the pattern continues, find the value of u8. So let's extend the series. 4, 7, 10, 13, 16, 19, 22, 25. The u8 is 1, 2, 3, 4, 5, 6, 7, 8. u8 is 25. Let's go to the next question. Find the first 4 terms of the sequence defined by the explicit formula un equals 2n plus 5. So this is the explicit formula where if we put the value of n, we get nth term. So it is asking us to find the first 4 terms. So let's find the first term first. u1 is going to be 2 times 1 plus 5. That is 7. u2 is going to be 2 times 2 plus 5. 9. u3 is going to be 2 times 3 plus 5. 11. And u4 is 2 times 4 plus 5. That is 13. That's the answer. Let's go to the next question. A sequence is defined by the explicit formula this. Find u1, u5 and u25. So u1 is going to be 3 times 1 minus 2. That is 1. u5 is going to be 3 times 5 minus 2. 3 times 5 is 15 minus 2, that is 13. u27, so that is 3 times 27 minus 2. 3 times 27 is 81. 81 minus 2 is 79. Let's go to the next question. Consider the number sequence -9, -6, -1, 6, 15. Which of these is the correct explicit formula for this sequence? So A says un equals n minus 10. So according to this formula, u1 must be 1 minus 10, that is -9. Is the first term of the sequence -9? Yes. Let's try the second term. u2 is going to be 2 minus 10, that is -8. Is the second term of the sequence -8? No. Therefore, this cannot be the formula. Let's try formula B, that is un equals n square minus 10. So according to this formula, let's take 1, 2, 3, third term. So u3 is going to be 3 square minus 10, that is 9 minus 10 or -1. So Third term comes out to be -1. This seems correct. Let's check the fifth term. So u5 is 5 square minus 10. That is 25 minus 10. And that is 15. This term also comes out to be true. Let's check all other terms. So u1 is 1 square minus 10. That is 1 minus 10 or -9. u1 also comes out to be true. Let's try u2. u2 is 2 square minus 10. That is 4 minus 10 or -6. So second term is -6. This is also correct. So we have tried first, second, third, and fifth term. Let's try the fourth term as well. u4. u4 comes out to be 4 square minus 10. That is 16 minus 10. That is 6. So fourth term is 6. So this is also correct. Therefore, we can say this is correct, because all the terms of the sequence shown here are justified by this formula. Let's try formula C. So C is un equals n cube minus 10. So let's take the fourth term. So u4 equals 4 cube minus 10. That is 64 minus 10. And that is 54. Is the fourth term of the sequence 54? No, fourth term is 6. That's why we can reject this formula. This is not the formula. So the question asks which of these is the correct explicit formula for this sequence. So we can say B is the correct explicit formula and A as well as C are not. Use the correct formula to find the 20th term of the sequence. So we know the correct formula is this one. If we find the 20th term, we get 20 square minus 10. That is 400 minus 10. That equals 390. That's the answer. Let's go to the next question. Write a description of the sequence and find the next two terms. The sequence starts at and each term is its previous term. So the general statement is the sequence starts at somewhere and each term is something to its previous term. Now for each question we need to fill these two blanks and that is going to be our answer. So let's say A. So we can see 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. And so on. We can write the next two terms as 40 and 48. And we can say the sequence starts at 8 and each term is 8 more than its previous term. So these are the two values that can be filled in this statement. Similarly, B. We can see 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17. So we can say the sequence starts at 2 and each term is 3 more than its previous term. Similarly, 36 minus 5 is 31, minus 5 is 26, minus 5 is 21, minus 5 is 16, and minus 5 is 11. So we can say the sequence starts at 36 and each term is 5 less than its previous term. D. 96 minus 7 is 89, minus 7 is 82, minus 7 is 75, minus 7 is 68, minus 7 is 61. So we can say the sequence starts at 96 and each term is 7 less than its previous term. E. 1 times 4 is 4, times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1024. So we can say the sequence starts at 1 and each term is 4 times its previous term. 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162, times 3 is 486. So we can say the sequence starts at 2 and each term is 3 times its previous term. G. 480 divided by 2 is 240, divided by 2 is 120, divided by 2 is 60, divided by 2 is 30, divided by 2 is 15. So we can say the sequence starts at 480 and each term is 1 by 2 times its previous term, or we can say half of its previous term. H. 243 divided by 3 is 81, divided by 3 is 27, divided by 3 is 9, divided by 3 is 3, divided by 3 is 1. So we can say the sequence starts at 243 and each term is 1 by 3 times its previous term, or 1/3 of its previous term. I. 50,000 divided by 5 is 10,000, divided by 5 is 2,000, divided by 5 is 400, divided by 5 is 80, divided by 5 is 16. So we can say the sequence starts at 50,000 and each term is 1 by 5 times its previous term, or we can say each term is 1/5 of its previous term. Let's go to the next question. A. 1, 4, 9, 16. Here we can see that this is equal to 1 square. This term is equal to 2 square. This term is equal to 3 square. This term is equal to 4 square. So the next two terms are going to be 5 square and 6 square. So we can say the next two terms are 25 and 36. Now it is also asking us to describe the sequence. So we can say each term is the square of n, where n is its position. So if it is the first term, it is the square of 1. If it is the second term, it is the square of 2. If it is the third term, it is the square of 3. And so on. B. 1, 8, 27, 64. Now similarly, we can see that this term is 1 cube, this is 2 cube, this is 3 cube, this is 4 cube. And similarly, we can say the next two terms are going to be 5 cube and 6 cube. And we can say the terms are 125 and 216. And we can say, and in the description, we can say each term is the cube of n, where n is its position. C. 2, 6, 12, 20. 2, 6, 12, 20. Here we can say this is the product of two numbers 1 times 2. This is the product of two numbers 2 times 3. This is the product of two numbers 3 times 4. This is the product of two numbers 4 times 5. So can we say the next two terms are going to be 5 times 6 and 6 times 7. So we can say the next term is 30 and 42. And in description, we say each term is n times n plus 1, where n is its position. So first term is 1 times 2, second term is 2 times 3, third term is 3 times 4, fourth term is 4 times 5. We can generalize this formula and we can say nth term is n times n plus 1. Let's go to the next question. So the red ones are for you to do on your own. I'll solve C, D, E, and F. C is 1, 16, 81, 256. Find the next two terms of the sequence. We can say this is 1 raised to the power 4, this is 2 raised to the power 4, this is 3 raised to the power 4, this is 4 raised to the power 4. So next two terms are going to be 5 raised to the power 4 and 6 raised to the power 4. So this is going to be 625, and the next term is going to be 1296. D. 2, 3, 5, 7, 11. What kind of sequence is it? We can see this is a sequence of prime numbers. So we can write the next two terms as 13 and 17. 2, 4, 7, 11. We know 2 plus 2 is 4, 4 plus 3 is 7. 7 plus 4 is 11. Now we can see that this difference is also forming a series where each term is 1 plus the previous term. Therefore, we can say the next term is going to be plus 5 and following term is going to be plus 6. Therefore, we can say 11 plus 5 is 16 and 16 plus 6 is 22. That's the answer. F 9, 8, 10, 7, 11. Here we can say 9 to 8, this is minus 1. 8 to 10 is plus 2. 10 to 7 is minus 3. 7 to 11 is plus 4. So can we say that this difference is forming a series with alternate sign every time? So the next term is going to be a negative number and the number is going to be 5, and the following number is going to be a positive number and that is going to be positive 6. So if we subtract 5 from 11, we get 6, and if we add 6 with 6, we get 12. So these two are the next two terms. That's the answer. Let's go to the next question. Evaluate the first 5 terms of the sequence. So this question is very easy. We just have to put the value of n for the first 5 terms. So for each question, we need to put the values as 1, 2, 3, 4, and 5 for each question. Those 5 are going to be the first 5 terms. So I'll solve only 2 of these. Others are for you to do on your own. I'll solve this one and I'll solve this one. Others are for you to do on your own. In number sequence, there is one more concept that you need to know, that if a formula, let's say 2n plus 1 is the formula for nth term, if it is written in curly braces, this means this is a sequence nth term of which is given by this formula. Now this formula is here. In curly braces, it means it is a complete sequence. Let's go back to our exercise. So here, these curly braces mean that it is a sequence of numbers. So let's calculate that sequence. For e, t1, that is first term, is going to be 1 square plus 2 times 1, that is 3. t2 is 2 square plus 2 times 2, that is 8. t3 is 3 square plus 2 times 3, that is 9 plus 6, 15. t4 is 4 square plus 2 times 4, 16 plus 8, that is 24. t5 is 5 square plus 2 times 5, 25 plus 10, 35. So n square plus 2n in curly braces means it is a sequence of numbers 3, 8, 15, 24, 35, and so on. I t1 equals 15 minus negative 2 raised to the power 1. This is 15 plus 2, 17. T2 is going to be 15 minus negative 2 raised to the power 2. That is going to be 15 minus 4, 11. T3, 15 minus negative 2 raised to the power 3. This is going to be 15 plus 8, 23. T4, 15 minus negative 2 raised to the power 4. So this whole term is going to be 16. 15 minus 16 is negative 1. T5, 15 minus negative 2 raised to the power 5. Negative 2 raised to the power 5 is negative 32. And 15 minus negative 32 is going to be 15 plus 32. That is 47. So here we can say 15 minus negative 2 raised to the power n in curly braces means 17, 11, 23, negative 1, 47, and so on. And this is the answer. That's it for this exercise. I'll see you in the next one.